How to configure RIP routing protocol, how to advertise routes out of a router through RIP routing protocol, how to configure passive interface, how to modify timers. These kind of configuration related questions the interviewer might ask us as well during an interview. So we need to have hands-on practice, and we should also be able to explain that how to do the configuration in a concise, summarized way. We don't need to go deep into the commands. So in simple words, if the interviewer asks us, how do you configure RIP routing protocol? So our answer should be, it is configured in three main steps. First step is to enable RIP using the router RIP command. This one. Simply router space RIP, just like we go with OSPF, router OSPF, router EIGRP, like that. So router is the command to go into the router configuration mode for the protocols. The second step is that we decide that whether we leave it to default version 1 or we want to make it version 2, RIP version 2. The third step is to advertise all the networks or to enable RIP on specific interfaces. For example, if this is a router we are going to configure, so we must enable RIP on this interface, we must enable RIP on this interface. Similarly here. So all these four interfaces. There is an example here shown, and also there is a RIP practice lab which I have shared with you guys. You can download the PDF. I'll give the link in the comments below, and you can download the Cisco packet tracer file and open the topology. I'll show you now. So mainly our answer should be three main steps to configure the basic of RIP routing protocol. Enable RIP routing on the whole router itself through the RIP routing router RIP command. Second one is decide the version, upgrade to version 2, so version space 2, which makes it RIP version 2. The third one is advertise on the specific interfaces or enable RIP on those ones. Let me show you the lab which I have prepared for you guys, and there is a specific lecture for lab as well which I have shared with you guys already. So please go to this playlist and you will find it over there. So there are two files of this RIP routing lab. This is lab 1. There are many labs which I prepared for you guys already. So here we can see that this is the RIP routing configuration lab PDF. Here we have topology diagram I prepared for you, and then the task says that you have to configure RIP routing protocol on these two routers. So this will give you the hands-on experience. All other IP addresses, PCs, everything is configured already. But if you want, you can take two routers, two PCs yourself in the packet tracer, and you can configure if you want to do further hands-on. But for this one, everything is configured. You just have to configure RIP so that your focus is on RIP. Then some background about the protocol like in all our labs. Then the solution. So we give you a clear task in every lab. We give you a packet tracer topology or GNS3 topology and a clear solution. So follow this step by step. Don't see the solution. Try to solve it yourself first. If you cannot, then go to the solution. After that, we go to the verification. So we must run the show IP route command so that we can verify, we can see the routes, and then we can also ping the interfaces. So this is a lab, and this is the complete solution if you want to implement on any other solution, any other platform other than packet tracer. Because this one contains the full configuration from host name, interface, IP address, enabling, and almost everything, right? And then some commands. So this is the lab which you guys have to go through, and then along with the lab we have this packet tracer topology. So open this, install Cisco packet tracer version 7 or version 6 point something, but better version 7 or onwards, higher version, and then you can open this topology in the Cisco packet tracer. Here you can configure. Let me continue as guest. Click on continue as guest, and it will take some time. So either we can log in, but sometime, even we log in again, it still keeps on asking. So I'll just go with the guest login. The guest doesn't allow you to save, but it allows you to configure and practice. Okay, so here we have these routers, we have these two computers. So here this packet tracer software, this is the simulation software. The version I'm using is version 8 here, this lab, but 7 will also support. So here we can go to CLI and we can run commands. We can, for example, we can run show version. So this is like a real-time experience of routers and switches. This is very good for practice. So this is how we can configure, and this is how we can practice. So three main steps. The answer to the interviewer is three main steps. Enable RIP, enable the version, decide the version, and third one, advertise the networks. So this is the interview question. I'll upload the files, this PDF file and the lab topology. If you can't find, you can write in the comments below. Okay, next question is which transport port is used by RIP version 1 and RIP version 2? First of all, do they use separate or same? So both of them, they use UDP port number 520. There are two types of ports on layer 4 transport. We have either TCP ports or either we have UDP type of ports. You already know TCP is for reliable transmission and UDP, user datagram protocol, is for fast transmission without any authentication, anything. So it uses UDP and it uses port number 520. Very important question. Okay, next question is what are the major differences between RIP version 1 and RIP version 2? So there are many differences, but mainly we can say 5 major differences between RIP 1 and RIP 2. First of all, RIP 1 is a classful type of protocol. It cannot send the subnet information in the routing updates. RIP version 2 is classless, which means it can support /25, it can support /26, anything. While RIP version 1 can only support 3 classes. It's a classful type of protocol. The second difference is RIP version 1 uses broadcasts for the updates. It does not use multicast. So it means it will be wasting so much bandwidth. Even some routers, they are not enabled with RIP, they will still be receiving these updates even they don't need it, right? While RIP version 2 only sends whoever needs the information, right? Whoever has tuned for RIP. So this uses multicast, this one uses broadcast. RIP version 1 broadcasts every 30 seconds, while RIP version 2 supports triggered updates as well. It sends the broadcast, sorry, not broadcast, it sends the the ongoing updates every 30 seconds, plus it also sends the triggered updates whenever a change occurs, right? So it does not wait for 30 seconds to be completed. Let's say it sends the update just now, the periodic update. Then after 5 seconds, a change has happened. A new interface came up or an old computer or router interface went down. So it will immediately send the triggered updates. So this is a major difference. RIP 1 does not do, RIP 2 does triggered updates as well. The fourth difference is that RIP 1 does not support VLSM, while RIP version 2 support variable length subnet mask, which I just explained to you guys. Then RIP version 1 does not support authentication, which means there is no security mechanism in RIP version 1, no availability, while RIP version 2 has authentication support. So either we can do plain text or we can go with MD5 type of authentication. So these are 5 major differences between the two versions of the RIP routing protocol. It has two versions, version 1, version 2. Version 1 is more older than version 2. That's why it's more simple, more lightweight, but very old, and we seldom use these days RIP version 1 wherever we have chance.